Hello and welcome to this fifth film about mole calculations. This one is the first of two about gas stoichiometry. We're going to kind of start with the simpler stuff, and that is equations that involve gas volumes and moles, and we're going to carry out some practice calculations. We're going to kind of stick to the year 11 stuff, so-called here, because strictly speaking, PV equals nRT is a 3b topic. But we end up covering it quite often in year 11 anyway, so it's going to come up in the next film anyway. So we're going to start with the slightly simpler stuff. We're going to look at the symbols and equations that we need for this. Okay, so we've got the number of moles, that's little n, the volume given in litres, that's capital V, and the molar volume, which is the volume of 1 mole of any gas. Okay, importantly, any gas, which is Vm. Okay, 22.71 litres is how much 1 mole of any gas will occupy at STP. This is given on your data sheet as 0 degrees centigrade and 100 kilopascals. Okay, this is the same as 273 Kelvin. Okay, right, let's have a look at the formulas we're going to use. Right, number of moles of any gas is given by its volume divided by this number, and the volume of any gas is given by its number of moles multiplied by that number. If you're a triangle sort of person, that means you've got the N down here, the V up there, and the Vm. Okay, let's just have a look at a question that deals with stoichiometry. And here is what volume of bromine gas is produced if 75.2 litres of chlorine react with HBr. Assume STP. Now, what do we know about gases at STP? We know that their molar volume is 22.71. So it doesn't matter what gas we've got, its molar volume, or the volume of 1 mole at this temperature and pressure, will be 22.71. We're told we've got 75.2 litres of that, and we're asked to find what volume of that will be. Let's have a look at the mole ratio here. It's 1 to 1. Well, if it doesn't matter what gas I've got, the molar volume will always be the same, then surely the volume of the gas is proportional to the number of moles. And this is something you'll look at later when you do gas laws. Alright? Volume is proportional to the number of moles, then the volume ratio must be the same as the mole ratio. So because the number of moles of bromine is the same as the number of moles of chlorine, the volume of bromine must be the same. We can only use this rule if the conditions don't change during the reaction. It doesn't have to be STP, but the conditions have to stay the same. So there's a little shortcut we can sometimes use. Moving on to another kind of question. How many grams of sodium chloride can be produced by the reaction of 0.112 litres of chlorine gas at STP with excess sodium? So we're being asked about this, and we're being told about this. Okay, 1 mole here, 2 moles there. We're told we've got 0.112 litres of chlorine. Okay, and we're asked to find the mass of sodium chloride. Well, the mass of sodium chloride is equal to the number of moles times its molar mass. I can look up the molar mass. That's easily found in the periodic table, but I don't know its number of moles yet. Can I relate the number of moles of sodium chloride to the number of moles of chlorine? Well, yes, they're related because they're in the same balanced equation, but the number of moles of sodium chloride is 2, and the number of moles of chlorine is 1. So the number of moles of sodium chloride is twice as large, or 2 over 1, times the number of moles of chlorine. What's the number of moles of chlorine? The number of moles of chlorine, well, I'm told its volume. So I can use this formula, equals V over Vn, which is 0.112 divided by 22.71. Let's just see what that is. 0.112 divided by 22.71. 4.93 times 10 to the minus 3 mole. So that's how many moles of chlorine I've got. The number of moles of sodium chloride, we just decided, is twice that number. 4.9. So I won't write it all out. Equals 2 times 2 equals 9.86 times 10 to the minus 3. And now I've got the number of moles of sodium chloride, right? So I can work out the mass. So the mass of sodium chloride equals 9.86 times 10 to the minus 3 multiplied by 22.99. 34.5. That's just from the periodic table, equals, so multiplied by 22.99, and that equals 0.76 grams. Okay, so there's the example question. We'll just move on to the next one because we don't want the film to be too long. An excess of hydrogen reacts with 14 grams of nitrogen. How many litres of ammonia are produced? Okay, there's our hydrogen. Okay, but we're told that's in excess. There's our nitrogen, 14 grams. How many litres of this? Volume, question mark. Let's write an expression for what being asked. The volume equals the number of moles times the molar volume. Okay, do we know what the molar volume is? Yes, it's 22.71 because we're doing it at STP. Okay, we're told it's STP, so we can use this molar volume. Do we know what the number of moles ammonia is? No, we don't yet, but we do know that it's 2 to every 1 nitrogen. Okay, so the number of moles of ammonia is 2, so that's 2 over 1 times as large as the number of moles of nitrogen. Okay, what's the number of moles of nitrogen? Well, look, hang on a minute, before we start launching into these new gas formulas, we're told we've got 14 grams of it. That's the mass over the molar mass we can use there. It's 14 over 28, which is 0.5. Okay, so I know that the number of moles of ammonia is 2 times 0.5, which is 1. Right, so the volume of ammonia, and again I'm writing an expression for the thing I'm trying to find, is equal to its number of moles, which is 1 times the molar volume, 22.71. How do we know it's that? Because we're at STP and don't need to get your calculator out to find that one, I don't think. It's 22.71 litres. Okay, so there's another stoichiometry question involving gases. I'm not even going to tell you what I normally tell you at the mole calculation stage. I'm just going to point you in the direction of what it says there. Okay. The next film to watch is the next one about gas stoichiometry, and it just moves on into the kind of year 12 material, but again keeps it fairly simple for now.